with 4.17. All right, so we have a displacement vector from your house to the library, 600 meters long, pointing at 25 degrees north of east. The x component is the east-west, and I'm guessing the y component is north-south. And always use, in this one they want 2 sig figs. So I would start off with a diagram. I'm going to grab, it's 4.17. Why don't you use your numbers? You're trying to figure out how to get through the wall, aren't you? There's a way through the wall right back there. Okay, I'll be flipping back and forth. I want to draw real quick. Then I'll be flipping back. So 4.17. So let's see. They tell me mine is 600 meters long and pointing 25 degrees north of east. So I'm going to establish that north is that direction, which means I start off pointing east, and then I swing 25 degrees north. So that's going to be that direction. So this is 600 meters, and this is 25 degrees. Just going to double check those. 600 meters long, 25 degrees north of east. So north of east, starts east and swings north. So there, that would be kind of the minimal vector diagram for this one to get credit on the y for it. All right. They asked me for my x and y components, so I'm going to draw in those components and make my right triangle. The one that goes east-west, they said call that x, so I'll call that x. And the one that goes north-south, they said to call y. And both those point in the positive direction, so I'm happy. Right? Now I have a right triangle. And I can use my friend SOHCAHTOA. And from SOHCAHTOA, I know that sine deals with the opposite side, and cosine deals with the adjacent side. So I know that, let's see, which one did they ask me for first? They asked me for my x first. So x equals my hypotenuse, 600 meters, cosine 25 degrees. Solve for x. And my y is my hypotenuse, 600 meters, sine 25 degrees. Solve for y. And that was it for that one. Huh? Okay. Yes, because cosine is adjacent over a hypotenuse, so the adjacent side is the hypotenuse times the cosine of the angle. Yep. Any other questions on this one? Do you want a minute to check your answers? Okay. All right. So 4.57. We drive east and then drive north. They want to know the magnitude, and they want to know how far north of east you point. Oh, so it's like the last one except the other way around, right? So to grab a vector sheet again, should just move these to the top. There we go. I moved going up? I'm going to grab my mouse. There we go. 4.57, I think, right? So I drive east and then north, was it? East and then north. So I'm going to drive east, and then I'm going to turn and drive north. And the displacement will be the red. So let's see, how far east? 640. How far north? 370. Let's call this D. And they also want to know what angle north of east. Oh, so I have a right triangle. Cool. So, how many things are there to know about a triangle? How many facts can you know about a triangle? 6. 3 sides, 3 angles. As long as I know 3 things, and one's an angle and one's a side, I'm guaranteed to be able to find the other 3. Do I know 3 things about this triangle? Yes. I know 2 sides and 1 angle. So I'm guaranteed to be able to find out everything I want to know about this triangle. It's just a little reassurance. Now it's a right triangle, right? We got this right angle down here. So I can use Pythagoras to find D, which says, Pythagoras of course says a squared plus b squared equals c squared. So I can take my 640 meters, square it, add my 370 meters, squared to it, and get d squared, and then find d. No. And then I want to find theta. I better check my problem. Theta is north of east. Is that what they, let's make sure that that's what they asked me for. Do they ask me for north of east? Yes, they do. So, my theta, let's see, 370 is opposite, 640 is adjacent. Oh, I can use tan, because that's the toe, right? So tan of theta is opposite 370 meters over adjacent 640 meters, right? Toe, tangent, opposite, over adjacent. Now to get theta, I need to do the arctan of both sides. So I get theta, because the arctan of tan is theta. Oops. Arctan of 370 meters over 640 meters. And that will get me theta. Some calculators, I don't say arctan as much as I say inverse tan. So you notice on some calculators it's tan with the exponent -1. Means the same thing as arctan. Just you say it inverse tan. I'll give you a minute to work. All right, truck route.
Yes.
I'm glad you like that. So, delivery truck travels 20 blocks south, 8 blocks west, and 14 blocks north. Assume the blocks are equal length. What distance has the truck traveled? What's the magnitude of the displacement? And what's the direction of the displacement of the truck from the origin? All right, so our vector diagram for this would be to draw the path of the truck. 20 blocks south, west, and then north. So I'm going to say that north is upwards. And I'm just looking ahead. Let's see, southwest. Okay. So I'm going to start over here. I'm going to go 20 blocks south. Then I'm going to turn and go 8 blocks west. And then I'm going to go 14 blocks north. And then I realize, oh, I drew it really small. So I'm going to redraw it bigger. And 14. Now, the first question, part A, says, what's the distance? What's the distance the truck traveled from the origin? What is distance? Total length traveled. Just like in the lab, right? So I'm just, for my total distance, mine's going to be 20 plus 8 plus 14. And then B and C ask me about the displacement. Well, let's draw in my displacement. My displacement goes from where I started in a straight line to where I ended up. Oh. Let's see, I could make that into a triangle with sides like that, right? Kind of completing out my rectangle there. Let's see, what angle do they ask me for? They ask me for south of west. Oh, that would be this angle here. Because west would be to the left, and south would be down, so that would be south of west. So let's see, let's call that length D. Horizontally, that side of the triangle would be 8, because it lines up with the other side of my rectangle. What's my vertical part going to be? 6. So to find D, I'm going to do Pythagoras again. This time I have 8 squared plus 6 squared equals D squared. And so D equals. And then to find theta, oh, I know the opposite and the adjacent again, right? So tan theta equals opposite 6 over adjacent 8. So I do the arctan of each side. I get theta equals arctan of 6 over 8. And that gives me theta. You guys notice a little pattern. Well, I got the 6 because a rectangle has equal sides that are opposite each other. And so if the right side of my rectangle is 20, the left side has to also be 20. So 14 plus 6 is 20. That's really how I got it. You know, you guys can open up the window on that computer to see the front board also. Okay. Yes, ma'am. Down below? Yes, and we'll do that. I'll show you. The only difficulty there, so let's say we have our D like that. You're saying, could we do this triangle? Okay. Right. And this would be D. This would still be 6. This would still be 8. But it asked us for the angle south of west. This isn't south of west. This is west of south. See, that would start south and pull west. So you would have to just say, oh, the theta I find there, the answer they want is 90 minus that answer. Because they want this angle up here. So yes, and you'll come out with the exact same length, the exact same displacement. You just have a different angle than the one they're asking for. It is, just because of what they asked for. All right, we're going to do 418. In gym class, you run 22 meters horizontally, then climb a rope vertically 5 meters. So let me draw that. Okay, so 22 meters and 5 meters. That means my displacement vector looks like that, and theta would be there. This would be d. What is the direction angle of your total displacement as measured from the horizontal? That's all. Oh, that's all they want. Okay. So I'm just going to do that tan of theta equals opposite over adjacent. So theta is the arctan of 5 meters over 22 meters. This is 4.18. And that's it. All right, folks. We're going to do 3.26. 3.26. And in 3.26, we've got vector A, which has 27 meters of points, direction 32 above the positive x-axis. So there's my vector A, 27, 32. It's 27 meters, and it points at 32 degrees. Then my B, 35 meters in points, direction 55 below the positive x-axis. So that would be kind of like this. And that one, my angle up here is 55. And that's 35 meters. All right. So notice I arranged them tail to tip, or head to tail, however you want to think about it. And now what I'm going to do is I want to figure out what is the resultant of adding those two together, this vector in red. Now, problem is that's not a right triangle, right? I'm going to make it into a right triangle, okay? And I'm going to do that by saying, okay, well, if I do, well, let's see, easiest way to think about this, yeah. If I do the components of each of these, I can end up making a right triangle by saying, okay, I've got C here, and it would have the parts add up to a whole, add up to the whole. So it's kind of like thinking about, okay, if I have, you know, if I've got a couple of boxes of stuff, and they're full of stuff, if I add up all the stuff, I get the same as adding up the two boxes, right? You know, so I'm going to add up my x components of these and get the x component of C, add up my y components and get my y component. So in the x direction, I've got the x part of the 27 plus the x part of the 35 that add together that way, right? Head to tail. Then I put, and I think I'm going to scroll down a little bit and move this, whoops, and move this down just a hair. There we go. And then I take and add to head to tail again the vertical part of the 27 to the vertical part of the 35. And I'm going to label this as X and Y. We'll call those are vectors A, I think. And then BX and BY. Have to arrange them head to tail so that they stay, so I take into account the directionality. So if I do AX plus BY, oops, sorry, AX plus BX. Let's use a new color. AX plus BX will tell me how long the component of C is in the X direction. So AX is 27 meters cosine 32. BX is 35 meters cosine 55 degrees. Add those together and I get the length of CX. Probably be nice in my drawing to label CX and CY. Then I can say, okay, well, to figure out CY, BY is bigger. So what I can do is say, okay, well, that would be BY minus AY will equal CY. And BY would be 35 meters sine 55 degrees minus 27 meters sine 32 degrees equals CY. Let's see, what do they want me to know? What do they want me to find out? They want me to find out the length of C and how many degrees below the x-axis. So I've got it set up where my theta is actually below the x-axis, right? So to figure out the length of C, it's going to be C squared equals CX squared plus CY squared, and I would find out what C is. And then this angle here, if I do this angle, call that angle theta, I can do tan of theta equals opposite CY over adjacent CX. Do the arctan of each side and get CY over CX. And that'll solve that theta. Jack, you got it? Yep. Do the math, let me know. I'm going to save the video because we only have 5 minutes left.